Okay, hello Year 10. This is just a video to run through the exam questions that I set you for the week 2 task for our forces topic on speed and velocity and distance and displacement. Okay, there was a set of exam questions that I asked you to have a go at, so I'm just going to run through the answers for those now and provide you with some feedback in general, and then I'll put some individual feedback and remarks on teams. Okay, so we'll start here at question 1, looking at a distance time graph for a person walking to a bus stop. Okay, the question asks which one of the following statements describes the motion of the person between points R and S. Okay, and we should realise that because they are the time is passing but their distance is not increasing, they are not moving. Okay. Next question says another person walking at constant speed travels the same distance to the bus stop in 200 seconds. Complete figure 2 to show a distance time graph for this person. Okay. So this is our figure 2. What we should have, okay, is that they should be reaching the bus stop in 500 seconds, okay, the same distance, which is 500 meters, but in the space of 200 seconds. Okay, they've walked the same distance, but they've done it in 200 seconds. Okay. Part B. A bus accelerates away from the bus stop at 2.5 meters per second squared. The total mass of the bus and the passengers is 14,000 kilograms. Calculate the resultant force needed to accelerate the bus and the passengers. So I'm just going to grab my calculator here so that you can. So what I should be doing is simply 14,000 times 2.5 gives me a resultant force of 35,000 newtons. Okay, and there's 2 marks there. Okay, next question, question number 2. Again, we're looking at a distance time graph. Okay, distance and time shows how far the car travelled and how long it took at various parts of the journey. Now it says in the table, between which points was the car travelling the fastest? And what we should have noticed is that based on the steepness of the curve of the lines, we should have identified that E to F is the steepest and therefore the car is travelling fastest. Between which points was the car stationary? So you should have said here between B and C, or between D and E. And you would have got a mark for either or both of those. Okay. Then you just needed to complete these sentences. Okay. When a car has to stop, the overall stopping distance is greater if the car is poorly maintained. There are adverse weather conditions. The car is travelling faster. The driver's reactions are slower. Also, the greater the speed of the car, then the greater the braking force needed to stop in a certain time. Okay, those are the 3 words that we wanted to try and put in there. Now, we haven't covered stopping distance yet, so it may be that this was new to you, but that's fine. Okay, that's something that will lead us into our next bit of work that we're coming to. Okay, let's move on to question 3. So, there's a graph here to show a distance a person walked on a short journey. Again, it's a distance time graph, so we're just reinforcing the same kind of information. It says choose from the phrases listed to complete the statements which follow. You may use each statement once more than once or not at all. So not all of them are going to get necessarily used, okay, and we could use them more than once. So between points A and B, the person is which of these? And we know that because it's distance time graph, and this is a straight line going upwards, we know that they are walking at a constant speed. Okay, and then between points B and C, and we should say that they are standing still, as we've already established. Okay. Then it says complete the sentence. You can tell that the speed of the person between points A and B is something than the speed between points C and D. So we're comparing those 2 points. So let's look again. A and B, C and D. So A and B is a steeper line, so we know that they're going faster if it is a steeper line. C and D, they would be going slower. So we can add something along the lines of faster in here, and we can say because the slope of the graph is steeper, or something very similar to that. Then I've asked you to write the equation which relates distance, speed and time. So this is one of those equations that you need to remember. Okay, now you need to have got it rearranged correctly. Okay, so you could have written speed equals distance over time. You could have written distance equals speed times time. Okay, you could have written time equals speed divided by distance, but try to get into the habit of using this one. Okay, let's move on to question 4. So a horse and a rider take part in a long distance race. The graph shows how far the horse and rider travel during the race. Again, it's a distance time graph. Okay, we're just using the same question, the same sort of graphs to reinforce our learning. What was the distance of the race overall? Okay, all we're looking at is where was the finish line, the track back, and it was 60 kilometers. Okay. Next question, how long did it take for the horse and rider to complete the race? Okay, so we're just going to again come down here and we're going to say that it was 5.5 hours, and we need to make sure we've included the unit. Okay, question C, what distance did the horse and rider travel in the first 2 hours of the race? So we go along to 2 hours, we work our way up, go back along, and we show that it was 30 kilometers. How long did the horse and rider stop and rest during the race? Now, this is our point of rest, we know, because it is stationary. How long was this time period between here and here? It was, now it's important to remember here that this time is in hours, so you might have written 30 minutes, which is not incorrect, okay, but because we're using the unit hours, we really should say 0.5 or half an hour. Okay, and you do need to include the unit there. The last part of question 4 says, not counting the time it was resting, between which 2 points was the horse moving the slowest? Okay, so obviously it wasn't moving at this point, so we know it was wasn't moving at all. Here it's quite steep, it's a little bit less steep, quite steep, and quite significantly less steep here. So our answer is going to be between D And E, give a reason for your answer, because it is the least steep part of the graph. Okay, question 5. So, a high-speed train accelerates at a constant rate in a straight line. The velocity, okay, of the train increases from 30 to 42 meters per second in 60 seconds. Calculate the change in velocity of the train. So we can just see that it is changing from 30 to 42, so we just need to take the starting velocity away from the finishing velocity, and that gives us an answer of 12 meters per second. Okay, now we get using this equation, okay, which is around acceleration. Now we are talking about acceleration in this week's topic, okay, but I've given you a question here about acceleration anyway to get you kind of thinking. So it says use the equation to calculate the acceleration of the train. Show clearly how you work out your answer and give the unit, choosing the unit from the list below. So we've got change in velocity, which is 12. So acceleration equals change in velocity, which was 12, divided by 60, okay, which gives us an answer of 0.2. Now what is the accepted unit for this? It is meters per second squared. Now that unit you may not have realised, okay, because I've only just given you the information about acceleration. So that is the unit for acceleration there. Okay, I think this is the last question. Says, which one of the graphs A, B or C shows how the velocity of the train changes as it accelerates? Write your answer A, B or C in the box. So you can see that this is a velocity time graph, okay, so here we've got, because it's velocity in time, we've got constant speed or constant velocity here, so it's moving. Here we've got an increasing velocity, okay, so it's going up, and here we've got an increasing velocity but at a different rate. So the answer we're looking for is B, okay, because that is the how the velocity is changing as it accelerates. Okay, so that concludes the answers for that set of questions. Okay, if you have any queries about any of that, please do let me know. I'm going to make sure this video has been posted for you and you have access to it. And good luck with this week's tasks.